Hello again, this is Mr. V. Hill. Today we're going to be talking about solving equations that require some simplification. Remember that the word solve in algebra and math terms actually means to undo what's being done to a variable. So you identify what's being done to that variable and you undo that thing with the opposite operation or the inverse operation. Fair warning though, this idea does break down in some instances. Next semester we will get into talking about what those instances are. And that was shown by Évariste Galois a while back, and we'll talk about that a little bit later on. But for our purposes right now, this is actually a pretty good way to think about solving. And so just really quick, we're going to do a little review from what you did on 7th grade, solving two-step equations. So here's our example. 5 times the quantity of x minus 4 is equal to 10. You might be tempted to simplify this side of the equation by applying the distributive property, distributing the 5 to the x and to the negative 4, but actually you don't need to. You certainly can if you want, but we cannot, since the unknown, or the variable x here is all by itself, we only see it in this one spot, we can identify the operations that are being done to x in order of operations. And so we might want to do is make a little table. For students who struggle with this, this usually helps out quite a bit. And so in this table, on the left-hand side, we're going to put the operations that are being done to the variable, in this case x. And on the right-hand side, we'll put the inverse operations, meaning the things that undo these various operations. And so we start out with what's inside the parentheses. First thing being done to this x is we're subtracting 4. So that's what we'll put right here, subtracting 4. The exact opposite of subtracting 4 from something is, of course, adding 4. And that's how you undo subtracting 4. After we subtract the 4, the next thing that happens is a multiplication by 5. And so, of course, the way to undo multiplying by 5 is to divide by 5. Or, of course, we could multiply by 1/5. Either way is going to work. And so, how we're going to undo these operations here is we're going to apply these inverse operations to both sides of the equation in reverse order. We can do that because if two things are equal and we do the same thing to each of them, the results are also going to be equal. So this equal sign will still hold. For our purposes right now, that pretty much holds. We'll see some instances where that doesn't hold in a little while. But a big thing here is that these things are being done to the variable in order of operations. We're going to undo them in reverse order. And the reason why we do that is because of the socks and shoes analogy. So, when you get up in the morning, you got to go outside, you got to put on your shoes and socks, right? So you put on your shoes first, or excuse me, you put on your socks first, and then your shoes. To undo that, you have to first take off your shoes and then take off your socks. That's the idea. If you take off your socks before you take off your shoes, well, you ruin your socks. Or you might make yourself a nice pair of leg warmers, but we don't want those because it's not the 1980s anymore. But anyways, let's apply these inverse operations to both sides of this equation in reverse order. So the first thing we're going to do is divide both sides by 5. And please keep in mind that you're not just dividing this number 5 by 5, we're dividing the entire side of the equation by 5. So I put the vinculum all the way across. And of course we've got to do it over here too so that the things will still remain equal. And then we just simplify a little bit. Since we have a factor of 5 on top and a factor of 5 on bottom, those things will cancel out. And we're left with just x minus 4 on the left-hand side. And we know that 10 divided by 5 is, of course, 2 on the right-hand side. Okay, so we've taken off our shoes. Now let's take off our socks. And therefore, we're going to add 4 to both sides in order to undo this subtracting 4. Because subtracting 4 and then adding 4, those cancel each other out. And so we're left with x on the left-hand side, and 2 plus 4 is, of course, 6 on the right-hand side. Sometimes we're going to present our solutions in set notation. For these types of equations, it's really not that important since there's only one solution here. But if you really want to do this, you can write your solution as a solution set, and we'll say that the solution set S is equal to the set of 6. It's not that important, but when we get into equations that have multiple solutions, you will need to put it into a set. But one other thing you have to remember to do is, of course, check your answer. And the way you do that is by taking your solution and plug it back into the original equation and see if you get a true statement out. So we ask ourselves, is it true that 5 times the quantity of, plug in 6 for x, minus 4, is that actually equal to 10? And so let's hear, 6 minus 4 is 2. 5 times 2, does that equal 10? Yeah, it does. We did it right. Fantastic. Okay, so that's the basic review of what you all did in 7th grade. But let's look at a little bit more difficult example. Here, this equation, 5 times the quantity of x plus 3 minus 8 times the quantity of 5 minus x equals 14. Now notice, here the variable or the unknown is showing up in 2 different spots. So we can't identify what's being done to this unknown or this variable because it's in 2 different places. Which instance are we talking about? So what we're going to have to do is simplify first. We're going to have to combine all the like terms. Now we can't do that right away now because this x is trapped inside parentheses, as is this x. Okay, so what we're going to have to do is simplify. And so first thing that I like to do, since there's subtractions in here, those tend to mess with people quite a bit. And so it's really easy to lose a negative sign. I hate that, so let's just switch this minus to plus the negative of the next thing, and also this minus as plus the negative of x. Now we're far less likely to lose our negative signs. Now we're going to simplify. We have a multiplication here, 5 times this sum, so 5 is going to distribute into both terms in there, and this factor of 8, negative 8, is going to distribute to both of the terms inside these parentheses. And so, rewriting the equation, we have 5 times x, which is, of course, 5x, plus 5 times 3, which is 15, plus negative 8 times 5 is negative 40, plus negative 8 times a negative x. Well, those negatives are going to cancel out, making a positive 8 times x. And that all equals 14. Great. Now we can combine these like terms. You might want to apply the commutative property to get them next to each other, but if you can handle this, no problem, that's fine. 5x is here, plus another 8x is there, makes 13x, plus, now we have 15 here, plus this other constant term, negative 40, which is negative 25. And now that is what equals 14. And now we're set up to just undo what's being done to this unknown x, because it's only in that one spot. Great. The operations and the inverses we can put into a table. First thing happening to x is it's being multiplied by 13. The way you undo that is dividing by 13. The next thing is adding negative 25. You undo that by adding a positive 25. So we're going to apply these inverse operations to both sides of the equation in reverse order. First, we will add 25 to both sides. Reason being that negative 25 plus 25 is 0. Those cancel out. So we have 13x is equal to 14 plus 25. That is, of course, 39. And then we've taken off our shoes. Now we can take off our socks, and we'll divide both sides by 13. Because 13 divided by 13 is 1, those cancel out. And we are left with x equals 39 divided by 13 is, of course, 3. And we can put that in set notation. So the solution set S is equal to the set of 3. Not a big deal. Most important thing really is just noticing that the unknown x has to be equal to 3. But, of course, we have to check first. Make sure we got it right. So we ask ourselves, do we get a true statement out of the original equation when we plug in 3 for x? So we ask ourselves, is 5 times the quantity of now 3 plus 3 minus 8 times the quantity of 5 minus 3, is that actually equal to 14? Let's see here, 3 plus 2 is 6, so that's 5 times 6 minus, let's see here, 5 minus 3 is 2, 8 times 2, does that equal 14? Well, 5 times 6 is 30, 8 times 2 is 16, and 30 minus 16 is absolutely 14, so yes, we did it right. Fabulous. And so I'm just going to leave you all with a couple of practice problems. So here we go. Go ahead and solve these. You'll need to simplify first because you see the unknown showing up in 2 different spots. But when you get your final answer, plug it back into the original equations to see if you get a true statement. Make sure you did it right. So go do these practice problems. No, don't go watch TV now. Do these practice problems. Do them. Do them now. I'll see you later.